So tonight there's a few working parts because we're doing the AGM at the beginning and then going to a regular meeting. And that means I've got a lot of files open and we're gonna have to do a lot of fiddling around, and so please be patient because we're still kind of figuring out all the how to do this all hybrid. And people online, if there's problems hearing what's going on, please text, and Randy's going to be watching things. He's also online at the back of the room, and we'll try and deal with things if you have trouble hearing. And when people that are joining us by Zoom want to talk, I'll have to take a second to turn the volume back up on the speakers, because if we have them up when I'm speaking, we get some feedback. So it gets a little bit complicated. So at this point, we haven't started either meeting. So we're going to do the AGM and then we'll adjourn the AGM. Hopefully it won't be very long, and then we'll have the regular meeting. But I'd like to start with an acknowledgement. So we respectfully acknowledge the territory in which we gather as the ancestral homelands of the Beothuk and the island of Newfoundland as the ancestral homelands of the Mi'kmaq and Beothuk. We would also like to recognize the Inuit of Nunatsiavut and Nunataqubit and the Innu of Nitassinan and their ancestors as the original people of Labrador. We strive for respectful relationships with all the peoples of this province as we search for collective healing and true reconciliation and honor this beautiful land together. So at that point, what I'm going to do is, so I've said a little bit about what's happening. That's the announcements part. So I'm going to now convene the AGM. And so I'm going to stop sharing this one. And this is the searching around. There's the AGM. And I'll do that. And I'm now convening the AGM. So the first thing we're going to have is the financial report. And so Jim, are you there? And what and I'm going to turn Jim back up now. Okay, this is going to be a problem because I need to speak at the same time. We may just have to deal with echoes. Jim, are you there?
I am here. Can you hear me?
Randy, are you? Okay. Yeah, okay. I think that was the problem. Okay, so Jim, I'm going to lower this screen, and unfortunately, every time I change screens, I have to stop sharing. Or do you want to? Can you share from your end, Jim?
I can try if that's easier for you.
Yeah, why don't you try that? So I'm going to stop sharing. You try sharing. And if you can't, I do have it as the PDF, okay? So the next part is the audit report. And Doug, can you unmute? And I can bring up your...
Yes, I'm ready to go.
Do you want me to bring up what you wrote?
Yes, please.
Okay, so I'll there we are, and share screen. So the next item is the membership report. And Randy, are you going to come down and do that?
No, you can read it.
Okay. So let me find my, oh boy, my mouse has disappeared. I can see it trying to be there, and it's...
I have a written copy if you want.
Okay, I'm going to share. There it is. Okay, so I'm going to share the screen. Okay, so Randy prepared the membership report. And Randy also points out that we had heard that a few members weren't planning to renew until we resumed in-person meetings. And hopefully we're now heading, well, where we've started that. So hopefully that's resolved. We're doing hybrid meetings. But we're also doing hybrid meetings because that allows people that are outside of St. John's, and we have members now that are very active that are involved. It allows them to be involved in the meetings as well, and people who still aren't quite comfortable meeting in person. We're expecting membership fees to increase. Well, the national has approved an increase in, I guess, the whole organization at the General Assembly, or the RESC AGM approved a membership fee increase, and we're hoping that won't discourage renewals. And the update as of a couple of days ago was that there are now 2 more new members. So there are 2 incomplete registrations. So if you are having trouble registering, please let us know that we've heard that some people are struggling a little bit with the online system. And if you let us know, that we can sort of help to move that through, at least to find out what's going on. So if you, and this applies to everybody, when you do come to renew, if you run into any issues, let us know, and we'll try and help with that as much as we can. Okay, so the next one is the president's report. So I'm going to stop sharing for a second, and I'm going to lower the and bring up the president's report. President's report, there it is. So this is my report on the activities for the last year, and last year was a transition. We started out entirely online, and then in the summer we started doing a little bit more in-person stuff. So we had online meetings every month, except of course July and August, and then September, the last meeting was a hybrid meeting. So we had a members meeting in October, which followed the AGM last year. Rick talked about the Webb telescope in November. Phil McCausland talked about the golden meteorite in December. Mahum Gaffar from Corner Brook talked about dark matter in January. Susan Redmond, there we are, talked about balloon-borne telescopes in February. And in March, Chris talked about Fermi bubbles, and we're going to hear a little bit more about them. We'll update tonight. Nikolai in April talked about satellite weather data. We had a members night and a report on the International Astronomy Day in May. I spoke about Ruth Northcott and Dora Russell in June, and then September we had reports on summer activities. So we've had pretty full set of meetings over the last year, and we've taken advantage of being online to have a lot of remote speakers, and hopefully people have appreciated. Lots of people have contributed to our programming.
Mike,
Yes.
all of the sessions are on the YouTube channel.
Yes. Oh, thank you very much. Yes. All of these sessions I've just mentioned, you can find on our YouTube channel. And if you're having trouble finding them, just email info@stjohnsresc.ca, and Randy will help you out. Can you get there from our website? There must be a way to get.
Yes, I'm not sure if Craig's, but I think Craig got it.
Yeah, so there are also links from the website. We had 2, in terms of recognitions, we had a presentation to Gary for his special service over many, many years. Last fall, Robert Babb received the RESC Service Award in the spring, and some of our members had images published. Jim Johnson had the North American Nebula published in the RESC Weekly Newsletter in July, and he has an image in this Messier Catalog Workbook. And Jim had the Cocoon Nebula in Sky News last year, and this lunar eclipse photo in the CBC Photos of the Week. That's right, right? And I've got a link there, which you can copy down real fast, or you can find it after Randy posts it. So we started going back to some public observing events. We tried International Day of Astronomy in May, Butterpot Star Party in August, and the Terra Nova Dark Sky Celebration in August. And just a few weeks ago, we did it International Observe the Moon Night. And we reported all of these, so I'll just remind you. The International Astronomy Day in May, we did it at the Geo Center, and in the afternoon, we tried to do some solar observing, but you can see what the sky looked like. So it was really just looking at telescopes, but we had members inside handing things out, and people in the ballroom helping out with questions about telescopes. And one of the things we are doing for our first, well, we're even still doing it a little bit for our public observing, is having some setups where the observing is done using electronically, basically using a screen, so that people don't have to line up and get close to a telescope. And so this was one of the setups for solar observing. In the evening, we set up, so this was, we did an observe the moon that night. Again, here's an example of using electronic observing. And it was mostly cloudy, so we didn't get an awful lot of people coming out, but it did clear right at the sort of end of our window, and two groups of about half a dozen people each came out and did manage to get a view of some things. The next thing we did was the Butterpot Star Party, and this was really a scaled down event. In the past, it's been much more of a social event for all members, and we, because we are still sort of on the edge of doing things remotely, we just focused on public viewing. So we had an afternoon, we had 2 evening sessions and an afternoon session. So the Friday and the Saturday evening and Saturday afternoon. And there were about 60 to 80 attendees at the Friday and the Saturday afternoon session, and maybe 100 Saturday evening. The Friday evening was a little bit cloudy, but people were able to see things. And these are just a few of the pictures of the people that were there. This is mostly during the day, with some solar observing set up, some personal solar telescopes, which just look at hydrogens, the red light from the sun. And I guess this one that Gary has is the same thing. I guess all of them, or there might have been one that was just using a metallized filter. And then in the evening, the Friday evening, you could see things, but there were clouds, things were coming and going. But the Saturday evening cleared up fairly nicely. Here's a few pictures from the Friday evening, and I think we were all pretty pleased with that. And then 5 of us went out to Terra Nova for their their night sky celebration at the end of August. And Doug Grushi is the chair of the Light Pollution Abatement and Committee, and the Dark Sky Preserve Committee, which is our subcommittee. And so he sort of organized things, and we collaborated with Dave Saunders, Yolanda Collins, and Kathy Sweetapple at with Parks Canada. And so we restricted it to the Saturday and Sunday. And this is the poster that actually Parks Canada made up that poster. It's nice looking poster. And so the Saturday, the weather was very threatening, so we actually set up earlier than we had advertised at the visitor center. And we had actually packed things up and there was a quite a violent storm. At the time we would have been scheduled to be there, but lots of people were able to see the sun, and it's a little hard to see, but Doug Rushi set up the solar system walk, which is little placards which Chris prepared, sort of spaced the same way they would be or proportional to their spacing in the solar system, along the shore from the dock to the parking lot along the side of the building. And there's Dave Newberry joined us for that. And then in the evening, we went to Sandy Pond, and it was just, it was really surprising because the afternoon, a couple hours before this, as I said, there was just a terrible storm. And then it cleared as quickly as it came, and you can see it was a beautiful night. This is a picture from Dave Newberry, and we have probably about 100 people there, and I think it turned out pretty well. Gary was there, and then let's see, I'm not quite sure how to make that go away, but whatever. Sometimes that disappears and sometimes it doesn't. So then on September 30th, we did an International Observe the Moon night. We had to start early because the moon set by about 9 o'clock. We figured we got about 130 visitors. That was at the Geo Center. We were very happy with that. Looking at the moon, Saturn, Jupiter, and some deep sky objects. And you can see sort of what the site looked like. There's what the phase of the moon was. And we had some people bring out their own telescopes. Here's Jim helping mother and daughter with their telescope. And I think we were very pleased again, as we were making this transition back to doing some in-person viewing with how it went. Randy?
They both joined now.
No, so they both joined. They were Emma and
Lord.
Lori. Okay. I'm not sure which one is which, but Emma's the daughter. Okay. And here's some more pictures from that evening. See Chris's 14-inch telescope and Robert's big refractor and whatever Randy's got there. Okay. The other thing that we started doing was, while we were doing presentations to outside groups, some of them were online. So I did a couple of talks to the CBS Scouts and the Clarenville Venturers during the winter about stars and constellations and stuff. And Cynthia and I actually went to Butterpot in June and did an observing session with the Pathfinders from Mount Pearl. But the bulk of the presentations to outside groups, as is often the case, were done by Gary. So he did the heavy lifting, and I've listed some of them here. Pippi Park, Rotary Park, presentations to Girl Guides and Brownies. So thank you very much, Gary. I think Gary's the name people have, so that works out well for me. And so thank you. And there were some media interviews. I did a few and Gary did some. CBC wanted to know about Uranus. Gary talked about a fireball that was observed in March. VOCM wanted to talk about Dark Sky Week. And Andy Bullman, who some of you may recognize from CBC, was doing a website article on dark skies and contacted us, and I eventually put them in touch with Doug Rushi and Jerry Ennis. And the article she wrote is, I've got the link for it here. And then I talked to VOCM a couple weeks ago about Jupiter being in opposition. And the other thing I just want to mention to you is that for members, we have it's called groups.io. So it's RASCNLtalk.groups.io. You have to be a member to join, and you can talk to Randy about getting on there. And I would encourage everybody to get on there. There's currently about 30 people on there, and I counted there were 3,600 postings last year. You can get them as emails, but that's a lot of email. What I do is I just go on sign on and just see the archive. And since we started that in March 2020, there's been over 2,000 photos posted, but it's also used for discussions of how to do different things. There's a discussion right now about, you know, how to design an observatory. And we have in the past had a few more of these Google Meets, but different members, and often it's Jim Johnson, can set up a meeting. Often it's coordinated through this talk group, where other members can just join up during the evening while either they're observing or they watch the host observing, and just talk about astronomy.
Didn't we do an extensive session during eclipse? 5 or 6 of us.
I think we must have, somehow I must have missed that. Yeah, so during the lunar eclipse, we were all online as well. Was that May 15th?
I think so, yeah.
Oh, well, that's that one. Okay. Yeah, so that was the one that I picked up. Okay. So that's my president's report. Any questions about that? Okay, so we should keep moving along. So I'm gonna get rid of that. I'm just gonna. I can actually close that one now. And do we have any committee reports? Do we normally do committee reports?
I guess so. Unless Robert's got something prepared for.
We do. I don't want to put people on the spot, but
There's no new information on the observatory project.
Okay. I see that Doug is unmuted. So Doug, do you have anything to report?
Well, yes, the Light Pollution Abatement Committee is a committee that we have, and also the Dark Sky Preserve Committee, which you mentioned as well. So I just want to mention that we have a Light Pollution Abatement Committee on the go. On chair, Mike is a member by the fact that he's a president, and we have 3 other members as well. We haven't met in a couple of years, since before COVID, but there's a lot of work to be done, and we would be looking for new members to make themselves available for this committee. So what is it? The Light Pollution Abatement Committee exists as a permanent committee with our national RASC, and it's a committee. We also have our own committee here in our center. And the mission of our committee is to work for social and legislative changes which will result in better, more responsible lighting practices in Canada and the preservation of the nighttime sky for all of us to enjoy. So how do we do it? We raise public and government awareness of the problem of light pollution. We form alliances with like-minded groups and organizations, and we make representations when we can get an audience to do so. So that's the Light Pollution Abatement Committee. Anyone interested in exploring the possibility of joining the committee, please contact. Well, you can contact Randy because you already have his contact information. You don't have to know anything about light pollution abatement to join the committee. We'll teach you what you need to know. And the first thing I'll say about light pollution is it's not an us versus them. Basically, you could start with you're in your own home. So just by closing your curtains or turning off your outdoor lights, changing the kind of lights in your home, little things like that, and you can start to make change for the better for light pollution abatement. One of our biggest successes is the subcommittee, the Dark Sky Preserve Committee, which actually is a committee of 2. It's me and it's Mike, by the fact that he is the president up to this point in time. So the committees have been on the go for a long time, long before I've been a member of it. And the big success is that Terranova National Park is a dark sky preserve, which is a designation that's bestowed upon it by the RASC, and our committee monitors the progress of the Dark Sky Preserve in Terra Nova National Park, and we've forged a relationship with them and helped them to continue to improve. So we could also use members on that. So with the Dark Sky Preserve Committee, we meet with Terra Nova National Park people. We do it online. They come to town. They come to St. John's, or we meet with them in person. We talk about their latest initiatives, any challenges they've had, and we provide our knowledge and expertise on how they can, continue to improve. And you don't need any specialized knowledge in that. Just come in, join the conversation, and we'll bring you up to speed. So that is my my report.
Okay, thanks, Doug. Are there any questions for Doug? So we just had the committee reports. So the next step is the elections. And so I'm going to call on Randy to explain what's going on and to introduce a special person who's creeping towards the front. And hopefully the people online can hear us.
Okay, and I'll pose the question for the third and final time. Are there any other nominations? Seeing none, I'll now entertain a motion to accept this slate. Okay, Jim Stacy moves, and seconded by Gary Diamond to accept the slate. Are we ready for the question?
Okay, and I can do it. So for the people online, we'll see if this works. I'm going to do it as a poll, and for the people, does that look okay?
That's fine.
Okay, so tell me when to push the launch button.
Okay, so first of all, is everyone online able to see this?
Okay, I've just launched it, and we'll just.
Okay. So we've got, okay, you've got one person responding,
And
now it's going up.
you should probably have these people voting at the same time.
Okay, so I'll also call the question in the room. All those in favor, please indicate. And anyone opposed? Is it, do we have guests in the end of the row here? So you're abstaining? You're voting in favor. Okay, in which case in the room it's unanimous.
Okay,
And we have online.
okay.
So I think that's unanimous approval. Thank you. My job is done for another year.
Not quite. So Randy, you should do it over here, so the.
As a gesture of appreciation, finally, you have to do something to get one of these. These are limited edition
Boxes.
collector's items. All right, they could open. So what they are is our center logo item.
Very nice.
That you taken by Fred Schmidt. So, oh, sorry, I can't see anyway. So
We can see you in there you are.
this one is the red one.
Oh,
Some people have the black one. You have the red one.
very good. So I'll throw it to the camera again. So let's see if we can get that nice. So. Well, thank you very much for that. I'm sick, I'm not expecting.
Figure out how to put that in there.
And thank you.
Thank you.
Okay, well, thank you very much, Dr. George. I'll end the poll. And so that's the AGM. Do I have a motion to adjourn the AGM? Okay, non-debatable, we're done. Okay, so now what I'm gonna do is I'm gonna stop sharing. I guess I've been re-elected president, so the new president then, I would like to thank everybody on the executive for all their hard work in the last year. And I don't know, there's a vote of thanks. And it has been a challenging year. We've started the transition from remote to in-person, and that required some complications. Let's see. There we are. And we do have one member leaving the executive, and that's Nikolai Demyanov. And I just want to thank him especially. I'm hoping that this is a sabbatical for him and not goodbye from the executive, but we'll see. I'll point out he joined the center in 2013 and became an executive member in 2014. So you don't have to be a long-time member to join the executive. And he's been on the executive originally as equipment and then as observing director since then. And so I'd just like to thank Nikolai for his hard work over the years. And hope that he gets rested up and makes himself available again in not too long. And I would encourage other people to think about how they, if they would like to get more involved in the activities of the center. As Doug was saying, you can become a committee member and sort of find out how things work, and that's often how people sort of move into executive. Or if you want to get involved in the executive, you can let us know, and we can find things for people to do, and give you an idea about what's going on. So I encourage you, if that's the case, to let Randy know, and we'll move from there. So the other thing I wanted to say is next meeting is going to be Dr. Terrence Trico, who's in the computer science department, talking about the modern era of computational astrophysics. So we have a speaker coming up for next month. I do have for visitors, Randy's already mentioned there are some benefits for being a member. Our meetings are open to everybody, but members, there's a supportive community to help you learn about astronomy. We've already talked about the chat group. There are publications, including the Observer's Handbook, equipment rentals, which Chris handles, and member observing sessions in Butterpot. And we haven't done many, but we have done one since the pandemic started, and we can hopefully move on from there. And if you're a member, you should be getting the weekly newsletter and the monthly bulletin. And if you're not, let us know. And so with that, I'm going to invite Chris to come up, and he's going to talk about Fermi bubbles. Oh, people online, I apologize. I don't think I was sharing the screen at that point, but I'm going to, oh, I see what I've done. Okay, so now I'm going to share the screen. Oh, and Chris, I'm going to get your video ready here. So your video is there in Firefox, okay? Okay. So I'll lower that. Now you'll have to stop sharing the screen to bring it up and then start sharing the screen. Good luck. Okay, so sharing the screen and full screen mode and move them down.
Make it just like a single, or you can put it there.
You need to get way down to.
Yeah. Yeah, we did all this in March.
Yeah.
How fast are you? It's a test.
There we are.
There we go.
Okay,
Okay, there you go. Yeah, oh, yeah, there you go. It's a reminder of a silly joke. Yeah, the talk in March, Galaxy's Fermi bubble, where's the graphic? Yeah, okay. Well, you get the idea. If you didn't see the talk in March, briefly, when they launched the satellite, that's at the beginning of this talk, there's this thing with the two big solar panels, Fermi telescope, and its mission was to look at the sky in gamma rays, named after this guy, Enrico Fermi. This was his first picture, and there are lots of gamma rays coming from the plane of our galaxy, and they were sort of expected. There's a mechanism called inverse Compton scattering, cosmic rays, and particles interact and photons interact. Photons get boosted, and they end up with gamma ray frequencies, lots of energy. There's how that telescope. We went through all this in March, yada yada yada. They kept looking. Fermi was integrating for longer and longer, and then they saw these two bubbles coming above and below the galaxy's plane, and it looked like something in the very center of the galaxy was burping, literally material, high energy material. And the question for the talk was, well, okay, we know there's a supermassive black hole in the center of the galaxy. As these things go, it's only 4 million solar masses. Since this talk, we've actually finally got a picture of it. That's not in the update, but that's everywhere. It's this orange donut. There are orange donuts over there after the talk, but you can think of those as supermassive black holes. Because if you eat enough of them, you become supermassive. But anyway, so Fermi bubbles. These are bright and gamma rays, and so energetic phenomenon producing these things. The idea is there a supermassive black hole in the center of the galaxy? The answer is yes. We've taken a picture of it, and is it eating stuff and thus generating burps? And is this dangerous for us living in the disk? And we went through that, and the gamma ray spectrum of the bubbles is hard as compared to the diffuse gamma ray spectrum for the disk of the galaxy. And so that indicated sort of a different mechanism. And there's inverse Compton scattering, low energy photon, high energy electron. The electron gives up its energy to the photon, and which leaves as a X-ray or gamma ray. Lots of other galaxies in the universe show bubbles from their supermassive black holes. There's a close-up of a supermassive black hole, a diagram of how they work. More pretty pictures, et cetera, et cetera. And we concluded, here's some evidence that, yes, there's something very massive at the center. Stars are moving out really, really quickly. And the thing that's there, it has no size, so it's a black hole. These guys got the Nobel Prize for all that work. If this was the PowerPoint slide, you'd see this little red splat in the beginning, which you can't really see in this, grow brighter and then fade over time. So our Milky Way is actually eating, but it's only snacking, no huge meals. And this is where I'm going to launch from. At one point, they thought they saw evidence for jets, which is a hallmark of active galactic nuclei, it's called. Galaxies that have supermassive black holes that are actively eating. And they thought they saw jets. And anyway, it went through, yes, the bubble's there, they're expanding. This is about 2.5 million years ago. Was there an extinction event 2.5 million years ago? Nothing big. Maybe, if something blew up really next door, maybe there'd be an extinction event, but the supermassive black hole is 27,000 light years away, so we're safe. And the talk ended, and because of all the double bubble, and the Milky Way, so I ended with a joke. And haha. So fast forward a few months, end of the summer, and I was lying in bed, it's first day of school, September 6th, I think it was. And the wife was out for a run, and her phone was there, and the radio was on, and weird radio news, like local radio station was talking about big news in the Fermi bubbles. I pinched myself to make sure I was actually awake. Why would VOCM be talking about the Fermi bubbles? I only talked about that a few months ago. So it turns out there was a major development. And to cut to the quick, I mean, the language in this newscast on VOCM, they're talking about gas stripping and low metallicity and dwarf spheroidals. I said, holy cow, it sounds like real astronomy here. Okay, so I picked up my wife's phone and I quickly looked up the news article, and yeah, it was real, and they got it right. They didn't get the facts too mixed up like I'm about to. So remember the jets, those jets. So evidence for those jets was really in that if you look carefully at some of those graphics of the gamma rays, there's an enhancement along the one wall for the southern bubble. There isn't any for the northern, and they called this the cocoon, and it's bright at higher gamma ray frequencies or energies, say 10 to 50 giga electron volts, and so on. So, hey, this maybe there's a jet hitting something at that point, and this is indication of something more of jets. And it was all very good and well, but then a little later, and I think this is concluded back in 2012. Fast forward a few years, and people went, hey, when you're looking in that direction, directly behind that is one of the satellite galaxies of the Milky Way, the Sagittarius dwarf spheroidal galaxy. Same line of sight. So we're here. The Sagittarius dwarf is there. You get all these nice loopy tidal streams of stars and gas being tidally ripped out of the Sagittarius dwarf by the galaxy's gravity. And so this is a stripped galaxy. There's no gas left in it. It doesn't form stars. There aren't many stars left in it. And our line of sight goes right through the bubble towards the galaxy. They're coincident. Incidentally, one of the Messier objects, M54, is a globular cluster, but it's at the core. It's of the Sagittarius dwarf spheroidal. It's actually part of that galaxy. And there are other globulars up in the sky, which are thought to have been captured by the Milky Way from that galaxy. Terzan 7, 8, and 9, Palmer 12, a bunch of things, some more sophisticated observers look at. Metal poor. What does metal poor mean? Just as a note. Astronomers call every element in the periodic table that's not hydrogen and helium a metal. Very simplified. Doesn't matter whether it conducts electricity or looks shiny, it's a metal if it's not hydrogen or helium. Very simple. Oxygen is the most common metal to an astronomer. So it's the third most common element in the universe. So a dwarf spheroidal galaxy is this one. Certainly, it's an old system. One way you can make hard gamma rays, they were one of the things they're thinking about for the gamma Fermi bubbles was that maybe there's a starburst happening at the center of the galaxy, an explosion of star formation, big massive stars, hot atmospheres, lots of energetic photons running around. And so one of those pretty pictures was a photograph of M82, which is a starburst, and NGC 3079, which is a starburst, and you saw those things coming out of it. No starburst in the center of our galaxy. And Sagittarius, the dwarf spheroidal, has no gas, so there's no star formation. The stars are formed from gas, no star formation. So how is this thing making gamma rays? And then somebody realized, wait a second, this is an evolved system. And when you have stars, evolved stars, some of those are going to be in binary pairs, and usually one star is more massive than the other. The more massive star evolves faster and does its thing, and really massive stars will fluff up as blue giants or red giants, and they'll usually go supernova, and what's left will compress under their own gravity into a neutron star, or even a black hole, but we'll say a neutron star. And then the companion will do its thing, and eventually it fluffs up too, but it's slower and less energetic because it's sun-like. I'll get there in a second. So this paper came out on September 5th. That's why it was all over the news. A fellow by the name of Roland Crocker. So you can see some graphics. There's a cocoon on the side of the southern bubble. There's a black spot in the north. Maybe they edited it out just for effect. I don't know. there's the cocoon, there's where the dwarf spheroidal is, same line of sight. I mean, they're right on top of one another. What a coincidence. But they were very careful, statistically and otherwise, to go through all this and make sure that, yeah, it's actually the dwarf spheroidal behind. They looked at the spectra and so on. So pulsars.
You want me to?
And at this point, yeah. We stop sharing? Where's the-
I'll do it.
Oh, right. It's only a 24-second YouTube clip. Let's see if we take less than 24 seconds to bring it up.
Okay, so I'll start sharing again and.
Yeah, just click and play, just in place, make it full screen.
Yeah, but I have to
Oh, sorry.
share it so we can see it. Okay,
yeah. So a pulsar, you have your neutron star that was created first, and it's very massive, even though it's tiny. The other star swells up, and when it swells up big enough, some of the matter can flow off of it and cross the gap and fall onto the neutron stars. The neutron star gets heavier and heavier, and like a figure skater, either getting heavier or pulling their arms in, it spins faster and faster and faster. And these things can spin up to the point where they become millisecond pulsars. Start sharing again.
I'll stop share again.
Stop share, and I'll let you drive because I don't know where you got all your windows.
And we just
So
need
Paul-
to find your talk again. There is.
So pulsars are, the jets are gamma ray bright. And some of those pulsars, the jets will be pointed more or less towards us. And we'd see gamma rays from that. And pulsars come from evolved objects, older objects. And they're not gas, they're evolved stars. So you don't, dwarf spheroidal, sure, why not? Thank you. So pulsars. And a cartoon that summarizes how to make a pulsar. And again, binary pair stars, they may not even be that particularly close. The massive one evolves first, eventually blows up and turns into a neutron star. The second one could be a sun-like star. Sun will turn into a red giant. When it's big and fluffy, some of the mass falls on the neutron star, eats it up, gets heavier, spins faster and faster. Those jets have gamma rays in them, gamma ray energies. Okay, dark matter searches, real quick. So this news is probably not great for people who look for dark matter because you've all heard of WIMPs as dark matter candidates, not people that get beaten up on playgrounds. So WIMPs, weakly interacting massive particles, have been since the 1980s a chief candidate for dark matter. They're actually, we've been searching so long and finding absolutely nothing for so long, and the searches get more and more sensitive that WIMPs are almost fallen off the radar now as a candidate, serious candidate. But some people are still looking, and a good place to look is in dwarf spheroidals, because the thinking is dwarf spheroidals are dark matter dominated. They've had a lot of the baryonic matter, the ordinary matter, stripped out of them. And so they have they're mostly dark matter. Other places people look is in the galactic center and in the sun even. A way of looking, well, one way of looking for dark matter is in huge vats of liquid xenon and other tanks that are buried deep in the rock to shield them from cosmic rays. But other people are deliberately looking at those cosmic rays with what are called Cherenkov telescopes. Big, crude optical telescopes that concentrate light. A gamma ray hits the upper atmosphere, creates a shower of particles, and you can observe the energy of the gamma ray. And for roughly the direction that you're looking in, if you're looking at the dwarf spheroidal, for example. Hess is in Namibia, is a bunch of these telescopes. It's a famous one for doing this sort of work. 10 years of searching finds no signs of dark matter annihilation. So they're not doing very well at this. It's a hard thing to do. But they keep coming up empty. Here they were searching at the galactic center. So 2018, they're going to search for gamma rays from the dwarf spheroidals, not only Sagittarius, the dwarf Sagittarius, whatever, but others. And now this comes. So here's the Leo 1 dwarf spheroidal. You can see it's barely there optically, right? But dark matter wise, maybe. So they look here too. Last slide. And now this comes along. So you can get gamma rays out of dwarf spheroidals without having dark matter in them at all. So it makes the hunt for dark matter all that much more difficult. This is how all of the news articles in September, early September ended. And so that's also how I'm going to end my little spiel here. Thanks. Yeah. Yes. Okay. Oh, there is one other news article I do want to point people's attention. Look up spaceweather.com yesterday. There's a big story about probably the brightest gamma ray burst in recorded history. So recorded history for gamma ray bursts would probably be in the last 75 years. Sorry?
On today's space weather.
Oh, excellent. Good. Yeah, look it up. It was so intense that it ionized the atmosphere, and people who do low frequency radio work with weird antennas that are in the ground saw it. So it's very cool. It's gamma rays, it's topical, and our atmosphere protected us this time. So thanks.
Okay, thank you very much, Chris. Okay, so I'm going to do a short news item about something that was in the news recently, and that was the double asteroid redirection test, which let's see, I need to. Okay, so you probably heard about this a couple weeks ago. This was this business about testing whether it would be possible to change the orbit of an asteroid. And I want to say a little bit about what they did and didn't show in that demonstration. So the idea was that they had this double asteroid system, Didymos and Dimorphos, orbits around Didymos. They just about a year ago, they launched this D.A.R.T probe, which is pretty simple. It's just it's moving fast, and it had a little cube satellite that it dropped off that sort of followed it, and it ran into this smaller asteroid, and they wanted to see if doing that would change its orbit. So the white here is the original orbit, the blue would be the new orbit, and this actually occurred close to Earth. So the dark blue in this picture is the Earth in its orbit. The magenta is D.A.R.T, so you see it's been launched and it's not getting that far away from Earth, but it's sort of moving away from Earth. And the green is this double asteroid system. And so the collision occurs there when it's actually fairly close to Earth. And there are two other asteroids that are represented on here, which we don't need to talk about right now. And so where this came from was that Didymos was discovered in 1996, and its partner, the small asteroid which became Dimorphos, wasn't discovered until 2003 by the Arecibo, oh, I spelled Arecibo wrong, telescope, basically by doing radar. So so this is radar, not an image, and it looks like you're looking down on it, but it's like weather radar, where the radar is actually looking across and sort of seeing things that are farther away. And the little dot here is Dimorphos sort of moving around relative to the bigger one. And the mass of Dimorphos is 5 billion kilograms, which sounds like a lot, but it's not that much. And it's going around, so this orbital speed is its speed around the bigger asteroid, 0.174 meters per second. I can do that. Right? I'm going 10 times that speed. So it's not moving very fast. It's radius is just a little more than, so the radius of that orbit is a little more than a kilometer, and it takes about 12 hours for Dimorphos to go around Didymos, and Didymos is about 100 times more massive. So really, what came first was the discovery of these pairs, and then people realized here's a very weakly gravitationally bound orbiting system, be very easy to perturb it. And so that's when they came up with the idea of doing this test. And that's when Dimorphos got its name, because di means two, morphos is shapes or something. Basically, its orbit was going to change. So that's where the di came from. That's what I read anyways. And orbit of this binary system brings it close to Earth about every 19 years. So do it now or wait for about 20 years. And so this system was attractive for this kind of test because it's such a weakly bound system. You only have to poke the little guy a little bit to change its orbit around the big guy. But I'll say something about what that means for the kinds of asteroids we might actually be worried about later on. So this is what the impact spacecraft looked like as in this sort of cartoon image. It's closing in on Dimorphos. There's Didymos in the background. The mass of the spacecraft is 570 kilograms. It's moving relative to Dimorphos at about 6,000 meters per second. So it's moving pretty fast. It's got a little ion engine here. And about the only instrument on it is called Draco, which is the Didymos Reconnaissance and Asteroid Camera. They always come up with the acronyms, right? They could have just called it the camera. And there's a little CubeSat following it. And I've already mentioned what the properties of the binary asteroid system are. And so I'm going to see if this works. So Cynthia and I were doing the dishes with YouTube on my iPad next to the sink, and it said D.A.R.T live. So we turned it on, and we actually saw literally the last 5 minutes, which was pretty cool. So this is sped up. It was actually doing an image every, I guess it was one image a second or something like that. And so the one here, the big one that it's going past right now is Didymos, and it's on its way past there and heading towards Dimorphos. And they'll slow down the video just for at the end to the actual rate. And so this is what we actually saw it coming in, and then bang, and that was the last one. And the people in the control room got very excited about that.
Dropping additions.
No, we didn't. It was pretty cool.
Oh, yeah.
I like it.
And so this image is 31 meters across. So you can see that it's basically a pile of rocks that are a few meters, very loosely packed together. And so this is called the rubble pile structure. Basically, Dimorphos doesn't have enough gravity. It doesn't have enough mass to become spherical, and actually Didymos probably doesn't either. So it's a very fluffy kind of asteroid. And in fact, one of the things that happened a few days later that was quite interesting was ground-based observations. This one was done by the Asteroid Terrestrial Impact Last Alert System. So last, I guess so, yeah. Atlas, which I think is in Hawaii. And so in this video, I'm sorry, it's very small. There's the impact. So you can't see the two of them. You're just seeing the whole system. You can see that there's, so in this picture, and it'll play again, the impactor's coming from the left in this image. It hits, and you can see there's a lot of dust that's splashed out, little rocks that are splashed out back in the direction that the impactor came from. And you know, a few days later, they were talking about it as being kind of an artificial comet. There was this big dust tail behind it, and there are lots of pictures like this. And so what I wanted to do was, and I did this before they actually figured out what the change was. What they were looking for was how big was the change in the orbital period. That's how they were going to assess whether it was successful or not. And just around the time that it was launched, this paper went through and did the analysis and said that in order to be able to observe a significant change, and so in order for the change to be big enough for it to be statistically significant, they had to change the orbital period of the little guy around the big guy by at least 73 seconds. That's out of 12 hours. So 12 hours is 428,000 seconds. But they were hoping to get more than that. So I actually went through a calculation using some mostly first year, maybe a little bit of second year physics to figure out what it should be. And this was before they actually released what the results were. But I got the same estimate that they were predicting. And so I'm using this information, the mass of the spacecraft, 570 kilograms, its speed relative to Dimorphos, 6,700 meters per second, and then these parameters about the binary system. And the first thing is that I treated it as an inelastic collision. So basically, in physics, that means that you've got two things that hit and they stick together. So this is an inelastic collision, that's an elastic collision. And that's the easiest assumption to make. But you could tell from the video that it wasn't a really great assumption because in fact, there was stuff splashed off. So there was a bit of that happening, but that's what I assumed. And from that, I figured out that the change in the orbital speed of Dimorphos would only be about a millimeter per second, about 3/4 of a millimeter per second. But remember, it wasn't moving very fast to start with, right? And from that, I was able to calculate, and you know, this was a back of the envelope calculation, but the envelope had to be an 8.5 by 11 manila envelope, and you had to write small. I had to write small. So the change in kinetic energy was about 670,000 joules out of a big number of joules, about a little less than 1%. But for context, a 100-watt light bulb burning for 1 hour dissipates 360,000 joules. So it's only about twice that. So it's not a huge change in the kinetic energy. But knowing about energy, you can say things about orbits. There's a connection between energy and the radius of orbit and the speed, which the radius of the orbit controls what's called the potential energy, the energy that essentially comes from the gravity. The speed controls the kinetic energy, and in a circular orbit, they aren't free to vary. They're coupled together. And so by using that kind of information, I could figure out that the change in orbital radius on assuming a circular orbit, it's not really, it's slightly elliptical, but it's pretty close to circular. So that's not a horrible assumption, would be about 10 meters. The orbit would get smaller on average by about 10 meters out of 1,190 meters. And then I used Kepler's third law, which you learn about in astronomy courses, which says that for something that's orbiting in a circular orbit anyways, the cube of the radius over the period squared stays the same, is constant. And that just depends on the mass of whatever's at the center of the orbit. And from that, I figured out that the period should decrease by about 550 seconds. That's a little more than 9 minutes. And I think that the prediction from the people who actually did it right was about 10 minutes. So that was pretty close. And then the actual observation, they said that the radius decreased by tens of meters, and it was 32 minutes, which was about 3 times what I came up with, or 19-20 seconds. And a lot of that was because of this splashback that increased the momentum transfer to the little thing. And the other thing is the mass for Dimorphos was probably a guess. They said 5 billion kilograms. Well, that sounds like a pretty round number. So what's that mean? Are we now safe? Can we quit worrying about asteroids? Well, if it makes you feel better, sure. But so here's the issue. We do know that there's no known asteroid that's greater than about 140 meters across that's likely to hit the Earth in the next 100 years or so. And that includes Didymos, which is 780 meters across. But scientists are pretty sure that they only know about 40% of those kinds of asteroids. So the problem, even more than stopping them, is figuring out which ones are going to be a problem. The other thing is that for this test, they were changing the orbit of something around a very tiny mass. For an Earth-threatening asteroid, what you're having to change is the orbit around the sun, which has a very big mass. And the velocity of an object that's orbiting the sun, the velocity in that orbit is going to be enormous compared to what we're talking about. And I don't want to get quantitative, but what it means is that there's going to have to, if there is a threat found, and again, the really big asteroids would be trouble, but they're known. The really small asteroids, they're not going to be so much trouble anyways. They could be inconvenient. It's these middle-sized asteroids like Didymos, or a little bit smaller than Didymos, that are the concern, because we don't know about them. But we're going to need to find them. That's the importance of things like this atlas. And I've got a link here for their website. Detecting the threats years in advance is important. And you're going to need a lot faster impactor, a lot more massive impactor, or maybe a whole fleet of impactors, or maybe impactors with bombs on them or something. You don't need asteroids to go up and drill a hole in the, or sorry, astronauts to go up and drill a hole in the asteroids. But you need lots of lead time. So, and you hear sometimes about these middle-sized asteroids that are sort of detected a couple months before they get here. Well, if that happens, we're out of luck. The ones that will be able to be protected from are ones that, have a close call, or maybe a couple close calls. People can calculate their orbits and then catch it, and figure out that, yes, it's going to hit in 100 years. I think the ones that are going to hit next week were out of luck. The Earth is a moving target, but that doesn't help very much, because the Earth is orbiting the sun, and whatever is going to hit us is also orbiting the sun. And we're likely going to be we're not going to be moving across the path of that object. The Earth moves very quickly. It gets out of the way in a couple of minutes if it's crossing a path. So you only have to delay something by a couple of minutes, but they're actually going to be traveling almost in the same direction. So it's going to take a lot more perturbation. So that's all I wanted to say about that. Just a little bit of an update. Yes. Oh, okay. Let me see. I'll have to bring this up and yes, so this was amusing for everybody. If you do D.A.R.T, NASA. And you see, this is probably why my computer doesn't work anymore, right? I've been doing that, and it's sort of bumped things.
I heard NASA was going to get charged with littering for that.
Okay, so the any questions? So we're good on that. So the next thing I want to do is I'm going to close that one and go very quickly through the. Oh, what happened there? Through some observations, and I'm not going to, because we're getting a little bit late, I'm not going to, I'll just sort of say what we're seeing, and I'm not going to invite people to say very much, but the things that people looked at over the last month, there was some planetary stuff, the moon, and some deep sky stuff. And so Jim did a couple of lovely pictures. And anybody know how to get this to get up out of the way? I've never, sometimes it disappears, but it doesn't always. So I can't actually see what date that was, but it wasn't not very long ago, 2 days ago. So Jim caught it just, there's Cabot Tower, the full moon coming up over Signal Hill, and then this was presumably a few minutes later. The moon and Jupiter, we didn't catch it the night they were closest together, but Cynthia and I got pictures of it. This was October 9th with a DSLR and a camera phone. And Bernard Day wins the challenge for last month, which was to see Neptune, but not only did he see Neptune, he saw Triton. So that's pretty impressive. And if you want to see the technical information about this, it's all on the RASC NL Talk. You can just go through the archives. A lot of the observing in the last month was Jupiter and Saturn. So I did some, and other people did as well. So I did some imaging using a Dobsonian, which can't track. So I basically imaged as with my DSLR on the where the eyepiece would go, did 30-second videos and then stacked them. There's Jupiter and Saturn. Chris Stevenson, you can see all the detail in this. So he's tracking and got a bigger telescope, lovely image of Jupiter, a lot of detail in the bands there. And this was helpful for people like me. Chris shared some of the settings. We use Registax to sharpen up an image like that using something called wavelets. And so Chris shared his settings, and I've tried those as well. And Chris also did Saturn. You can see lovely detail in the rings there, the gap.
Probably my last ever Saturn picture from the yard with the trees. That was photographed through leaves as it was.
Okay. Oh, so that's why it's a bit soft.
Yeah.
And so I did a nut. So I tried switching to a refractor on a tracking mount and using a 2x Barlow. So it's just an 80 millimeter. There's my Saturn and Jupiter with that one. And I also did the same thing and got the red spot. That was just a few days ago. Well, a week or so ago, 10 days ago. And I tried a an actual planetary camera, a black and white camera, and got a little more detail, a lot more detail. And Jim did the same thing. He used the same kind of camera, I guess, with his 4-inch, got lots of detail. I guess that's the red spot there.
I don't know. I think there's
Might be.
just additional bands.
Yep. And nice shot of Saturn. Those are black and white cameras. I did some images of the sun. The sun is getting more active. So anybody who's got a solar scope or has a filter, there are getting to be lots of sunspots and some interesting prominences. And then we get into the some of the deep sky stuff. So Jim Johnson did the Cocoon Nebula. John Nugent has been doing some very long acquisitions. So this is his Andromeda Galaxy, 19.7 hours, and he's got all the details here. He's sort of gone from 0 to 60 in a very short amount of time. And Bernard Day, of course, has an observatory out. Where is he? He's in Central. By Lewisport, yeah. So this is the Bubble Nebula, and there's no question that it looks like a bubble in that picture. So he's got a very nice observatory there. Lots of nice stuff. Jim did the Triangulum Galaxy, and so you're actually doing this with a telephoto lens on a camera. So, but tracking and doing and guiding the whole bit. So. And Robert, this is NGC 7822. Where is that in the sky? That's okay. Okay, and really getting some nice results with this filter that does oxygen and hydrogen alpha, right? Yeah. And another, so this is John Nugent's Triangulum Galaxy. Again, this one is 13.2 hours, and that's what I've got for that. And did we end up with a sky this month, or
No, we never, no. Online.
no? It didn't get posted.
Didn't get,
So
there was some confusion between myself and Nikolai. And just yesterday or today, I found out that what he sent, which I thought was October, was actually September.
okay, it was a template.
Yes.
Okay.
Yeah, so it'll be updated and put back on the website in a day or so. Nikolai's in Bulgaria.
Yeah. So sometimes it goes away. So yeah, so the sky this month will be posted. So what's in there is the sunrise and sunset times, meteor showers. There are 2 meteor showers coming up
Yes, that's right.
this month. Gary, do you know what they are? The Orionids and I think Taurids might be it. Yeah, one in October, one very soon, and one in the middle of November.
To the good old handbook, October 21st, the Orionids. And November 5th is before the next meeting, the south towards, and November 12th, north towards. Yeah.
Okay, and Mars is starting to get into the
Yes.
evening sky. Have you started looking at Mars, Gary? Of course. Gary doesn't. Mars doesn't get away unmolested when Gary's got his telescope. So, but it's going to be starting to be up early enough for everybody else to look at it too. And the other thing that's coming up is a lunar eclipse in November. Chris has the handbook. Could you check November for when that is? Now,
Test, right? How fast can you think he's gonna go?
yeah, I was just going to say, it's going to be at totality when
Okay,
when the moon sets.
So the tabs on the left hand, the little gray tabs are marvelous.
Okay.
So I got this one for you. November 8th. if you were in Africa, okay, maybe not.
We get all.
But it's gonna happen, like Randy said, about 4 a.m, but
Yeah. Yeah.
some of us are old and get up in the middle of the night anyway, so some of us might see it. And I'm not commenting one way or the other, but
Yeah.
View of the horizon.
yes, because it's gonna be very low at that point. Okay, so that wraps up the sky this month. I'll just say that next month, we're having Terry Trico, who did his undergraduate here. And then he went to Australia. He was a postdoc in the United Kingdom and at Toronto, and now he's back in computer science, and he's computational, but he's applying sort of fluid dynamics to the way galaxies work. It's pretty interesting stuff. And the other little piece of news I'll just mention is that the Lucy probe, if any of you know about that, it's a very long-term project. It was launched about a year ago, maybe a little less, but it's going to swing around the Earth a couple times, get gravity assists, until it gets enough juice to get up to the orbit of Jupiter. And then there are a group of asteroids called the Trojan asteroids, some that are orbiting with Jupiter, ahead of Jupiter, and some behind. It's going to go and image half a dozen of one of that group, come back, loop around the Earth again, and this is going to be several years from now, or many years from now, maybe 12 years or something.
Yeah, I think the 2030s.
And then go back and get the other ones. And the Lucy comes from, even though the newspapers always say Lucy in the sky with diamonds,
Yeah.
my understanding is that it's Lucy the
Australopithecus.
yeah, the
early skull.
Oh.
early hominid that was found in Africa that sort of told paleontologists about how we came, Richard Leakey is, how humans sort of developed. And the idea is that this one's going to be looking at asteroids because they are remnants of the beginning of the solar system, and they're going to be like the Lucy for solar system dynamics. And on the way, and I don't know if it's an accident or not, it's going to go past an asteroid which has been named for the guy who discovered the Lucy skeleton. That sounds a little too convenient to me, but anyways, at some point in the future, I may give a little talk about that, because the physics involved in these 3 loops and in what's happening out at these Lagrange points is pretty interesting. And so somewhere in the winter, maybe you're going to hear a bit more about Lucy. That's it. We're done.
All right.
Last weekend, I think it was 300 miles.
So they actually were, when it was coming in, they were keeping an eye on this. It was getting close enough to the Earth, because it needs to get close enough to the Earth to get enough of a kick from the Earth's gravity, because it's getting slingshot back out. They were looking at other satellites to see if they had to move them.
Oh, I was just going to point out also another probe made a close swing past a body. Juno at Jupiter passed over the ice of Europa closer than we have in 20 years since the Galileo probes did it, and took some very sharp images of the surface of that. And of course, we all think that under that ice, there may be life in a big ocean. So
Okay, so thank you. I guess only Peggy and Doug have hung in. But thank you for, or you still have 9? Okay, I'm not seeing everybody then. Oh, sorry. Okay, everybody's still there. Thank you all for hanging in. I'm sorry about all the flipping back and forth between screens. There was a lot of moving parts for this meeting, but there we are.
good job.
So I'll leave. I'll stop sharing. I'll leave this up here. If anybody that's online wants to say hi or you can just unmute and yell and, yes, Randy. Okay, so sorry, people at home. Susan says thanks. You'll have to make your own donuts and coffee. But thanks again for being here and for joining us, and let us, oh, and people at home, if you got any comments about the mechanics of making this work, any suggestions, we'd welcome them because we're still kind of figuring it out. Bye. I'll leave the connection up until people are gone. Donut time. Switching back and forth.